Alright guys, so let's understand what fork system call is. So let's begin. What fork does is that whenever it's invoked, it will duplicate your current process and will create a new process named as a child process. So why have we named this as a child process and this as a parent process? The reason is that there exists a relationship between these two processes, which is inheritance. For example, your parent has black hairs and you also have black hair. So you can say that I have inherited my hair from my parents. So how this relates here? This relates here is that, for example, I have declared three variables in the parent process of integer type and I have given each of them a value of 5. So when I will fork the parent process, the child process will also possess these three integer variables having a value of 5. So you can say that whatever the attributes or whatever the data types the parent possess, the child process will also possess these things, these attributes. So that's the concept of inheritance that is used here. Now, if a parent process and a child process holds the same thing, then what's the difference? What's the use? What's the advantage we are getting here? Now, the difference between these two processes is that the parent process has its own address space and the child process also possess its own address space, meaning that if for example my mind changes and I want to declare each of variable with the value 6, so I increment each variable with 1 and now the each three variables possess the value 6 instead of 5. So what will happen by making this change? Will child also do the same thing, that is initializing all the variables with 3 with 6? No, that is because this thing I have done, it is done in the parent address space and the child address space is different. So child will not show any effects of changing in the parents. Instead, it will still go on with the value 5. So that's a main difference. And for example, if I plan to decrease each value integer in the child by 1, so for example, the three variables will be assigned now the four values. This chain will also not be shown in the parent process because it possesses its own address space and it possesses its own address space. So that's the basic whole concept of forking. And now let's discuss it from the coding point of view.
Okay guys, so I'm using Linux operating system here on my virtual machine installed on Windows. So if you're using Mac operating system, then you can simply just open up the terminal and compile your code there. It will work the same. So I'm going to use C language in this whole series. So now just to begin with, I'm going to open up the terminal and I'm going to create a .c file here. So for that, I'm going to use the touch command. Basically, what touch command does is that it creates uh, a new file, basically in the specified directory, which is the folder I've created here, and with the name and an extension. So part1.c, just try name this been created. Now let's just write a basic C program here. Okay, now to compile this program, we will use GCC and then the name of our file. So now if you were using C++, you would like just G++ since it's a GNU based compiler. Okay. Okay, my bad. Just comma, comma over there. And you can see if there is any error in the program, it will just show you. Now I, okay. So you see there is no error in the program and just compiled successfully. Now let's just use the clear command to clear the screen. Okay. So now you will see that in your folder there will be file name a.out. So it just basically is compiled into a.out and now we're going to execute it. Slash a.out. As you can see, it prints variable x equals to 5. So now let's just go over the syntax of fork system call. So whenever the fork system call is invoked, it will return three types of value. One will be negative and one will be 0 and one will be greater than 0. So if the fork has returned a negative value, that means you have encountered with the error. You can say there is some error in the creation of the process. So if it has returned 0 value, that means currently you will be in a child process. And if it has returned value greater than 0, then that means you are in the parent process. So now we will be going to use the fork system call. Just write fork uh, right just after the main, like that, with the function parenthesis. Since it's going to return some value, so let's just keep that value in an integer named y. So now let's just compile the program. Okay, so just C part1.c. As you can see, it has thrown some exception here. It is saying that warning of fork. So it's not recognizing the fork here. That means that we haven't included the correct library. So I have deliberately done this so that you can keep remember the name of the library, which is unistd.h. So this library basically includes fork system calls and other we will discuss in the future. So now let's just compile again, and you can see it has compiled successfully. So now let's just execute the file. As you can see, it has printed 2 times, and I have written it only here 1 time. So that means a process has been duplicated. Now, how will we see that either of them is a child or parent? So I have just recently shown you that if fork returns 0, that means it's in the child process, and if it's greater than 0, that means we are here in the parent process. So let's just put here a condition that if y equals to 0, that means we are here in the child process, and else it's going to be either error or parent. Since the fork is working perfect here, so we are ignoring the error condition and assume it to be parent. Variable parent x equals to t here and x. Similarly, we will write just child here and with. So now let's just compile it. Okay, so there's semicolon error here, no problem. Okay. Okay, it has compiled successfully. Let's just clear the screen. So now let's just execute it. And as you can see that parent and child separately has been written. So now it is not sure, the order is not granted here, whether the child will come first or parent, since the both processes are running concurrently, which we will discuss in the further upcoming videos.